Okay, so this is the grade 7 test video review series for books 1, 2, and 3. This really is the closest thing to what the state tests are going to be like this year. This is the closest thing. So first of all, we're going to go through book 1. So let's take a look at the first question. Okay, so here's the question. So we're told about elevation, and we're told about something being at negative 424.3 meters and the mountain, Mount Everest, being at 8844.43. So if we're after the how much higher the summit is, we're really after the difference. So when dealing with difference, we've got to subtract. So we've just got to be careful what exactly it is that we're subtracting. So I'm just getting everything ready right here. Okay, so in this question, we in fact have to take the biggest number, which is 8844.43, and we are subtracting. Now we've got to be careful, we're subtracting a negative. So when we subtract a negative 424.3, we're actually adding. So when we do 8844.43 minus negative 424.3, we're actually adding. So I'm just going to put add underneath and then line them up, 424.3. When you add these, the 3 drops, the 7 comes, the point comes, the 8, 6, 4 plus 8 is 12, 2 carry the 1. So that's 1268.43. Sorry, 9. 1 plus 8 is obviously 9. Okay, so D is our answer. So this question, if we just look back a second, we're dealing with a mountain, and we're dealing with the summit, so the summit's at the top, and the height of this is 8844.43. Now, if we imagine that 0, the ground is here, and we're told that the Dead Sea is negative 424.3, we're told that this sea is actually below the regular ground level of the Earth. So that's why we in fact have to go from 8844 all the way past 0, all the way down. So that's in fact why we end up turning this minus and negative into a plus. So that's our answer to number 1. As for the sample space, and even if we're not, the sample space can always help us. The things that could happen when we roll a die are we could get a 1, 2, 3, 4, 5, or 6. So 6 possible things could happen. Now, we're only after the probability of rolling an even. So we know that 6 possible things could happen, and over here a 2's even, a 4's even, and a 6 is even. So that's 3 things out of 6. That's our probability of rolling an even. Now when I look here, I don't see 3 over 6, so I've got to question my answer. Is it a good answer? Well, it is good, but we can simplify it. We can divide the top by 3. We can divide the bottom by 3. So this gives us an answer of 1 over 2, which is C. Okay, let's take a look at number 3. So number 3 is asking us how 5/16 can be written as a decimal. So fractions are division, and when we convert a fraction into a decimal, we would divide. So in this case, the 5 would go in the house. The 5 would go in the house. Let me just clean this up a little. The 5 would go in the house, and the 16 would go out of the house. So we know 16 can't fit into 5, so we put a point and make it look like 50. So 16 into 50 goes 3 times. Now, we must make sure to leave our point there, because 16 into 5 goes 0. Now, 3 16s are 48. When we subtract it, we get 2. But really, at this point, if we're smart about this, if we're working smarter, not harder, we don't need to continue with this decimal. We're done with this answer, because when we look through our possible answers, A doesn't start 0.3, B starts 0.3, so it's looking good for B, C doesn't start 0.3, and 11 is nowhere near the answer. So at this point, we do not need to continue. They are not going to check our answers in our multiple choice, we can just say B. Even though our answer of 0.3 doesn't match it, we know we're going to get some numbers after, and it has to be B. But let's continue anyway. So now we've got to do another 0, bring it down. 16 into 20 goes once. 1 times 16 is 16. Subtract, we're left with 4. Now we've got to continue and bring another 0 down. 16 into 40 goes twice. 2 times 16 is 32. Subtract. We get 8. Bring down another 0, and 16 into 80 goes 5. So it does in fact match B completely, but just bear in mind that as soon as you've got 0.3, you know that B is the only answer that starts 0.3. So it has to be B at that point. So just do the next question, move on. Okay, let's take a look at question number 4. So 4 is a fun question because it's likely they're going to give you this. And it's a circle on top of a grid, and we don't see this very often. But here we're told the figure shows a circle graphed on a coordinate plane. What is, so our question's right here, what is the approximate circumference of the circle? So as soon as you hear the word circumference, you could underline it and you could write the formula, C equals 2 pi r. Now some people remember the other one, C equals pi d. Both are the same, but this is the one that I always seem to remember. Okay, we just got to be careful. Are we dealing with the radius or are we dealing with the diameter? So it says approximate, so we kind of like that. We don't have to be exact. Now when I'm looking at the circle, it's kind of hard with all of these numbers everywhere, but it looks to me like this is pretty much the middle. So if that's pretty much the middle, and I've got my formula C equals 2 pi r, I need the radius. So my radius is going to be the distance from the center of a circle to the circumference. So this is r. So if I count, I've got 1 unit, 2 units, 3 units, 4 units. So therefore r equals 4. Now there's another little trick here as well, because if we're using C equals 2 pi r, and we know that the radius is 4, we know 2 is going to come down. Now pi, usually, if we don't have a calculator, we say let it equal 3.14. But here, we notice something in our answers, A, B, C, and D. They're all very different. 12.6 is nowhere near 25.1, which is nowhere near 39.5, and that's very different to 50.3. So that shows me that I'm allowed to estimate a little more. So we're going to break a rule and we're going to say pretend that pi equals 3. Now in pretending that pi equals 3, 2 times 3 is 6 times 4 is 24. Now if I look at my answers, well, the closest one is 25.5. So therefore I know my answer is B. And we don't get 25.1 here because we used pi as 3. But we accepted that we're estimating, so we know it's going to be a little off, but it's not going to be as far off as 39.5 or 50.3. If you wanted to use 3.14, you could do that and you get much closer. Okay, that was number 4. Let's take a look. Number 5. Okay, so in this question, whenever I'm told about probability and people having so many things on their desk and all that stuff, I just like to draw this stuff. So we're told 4 pencils. So you could draw it or you could write it. So I'm going to write pencil, pencil. And I'm writing it because if I just use P, I don't know if it's a pen or a pencil. So I'm writing the whole word here. So 4 pencils. Also a blue pen that's blue. And also a pen that's black. So far I don't even know the question. I'm just taking out all of this stuff. I don't even need to read this stuff anymore. So if he randomly draws 2 of them from the desk without replacement, this is very important as well, he's not putting them back. What is the probability that he will draw 2 pens? So the question is really asking us for probability of getting a pen and another pen, and remember, he's not replacing this. So the first thing I'm going to do is count how many things are there. I've got 1, 2, 3, 4, 5, 6. So 6 things there. And so the probability of taking a pen as the first thing, thank you. The probability of taking a pen as the first thing is going to be 1 out of 6. Sorry, 2. There are 2 pens here. This is a pen, this is a pen. So there's 2 opportunities to choose a pen out of 6. Now, the probability of choosing a pen for the second thing, if a pen's gone for the first thing, there's now only one pen there. And also there's no longer 6 things on this table. There's only 5 things on the table. So the probability of choosing a pen the first time is 2 out of 6. And if a pen's already chosen the first time, the probability of choosing a pen the second time is 1 out of 5. When it's probability of something and something, we're going to multiply. 2 times 1, 2. 6 times 5, 30. Our answer is 2 over 30. Now I don't see 2 over 30 there, and that's because we can simplify. 2 over 30, if we divide by 2, it becomes 1 over 15. So C is our answer for number 5. In number 6. In number 6, we are told a bunch of things. We are told that she spends 7 3/5 hours in school. So I'm going to write it. 7 3 over 5 hours in school. So this is a total amount of time in school. We know that the lunch is 1/2 of an hour. We know that the amount of time switching, so that was the lunch right here, the amount of time switching is 7 over 10ths of an hour. And this is the amount of time switching between classes. So I'm assuming that every single hour, every single second of the rest of the day is spent in a classroom. So that's the teaching time. And it wants to know if the rest of her day is spent in 6 classes that are all the same length, how long is each class? So first of all, we've got to subtract these 2 things from the 7 3/5. So to do this, I'm going to convert my 7 3/5 to an improper fraction. So 5 times 7 is 35, plus the 3 gives me 38. So it's 38 over 5. Now I'm going to subtract 1 over 2, and then subtract 7 over 10. So let's turn these into fractions with common denominators. 10 looks like it's a good common denominator to use. 7 over 10 stays the same. 1/2 turns to 5 over 10. And 38 turns to 76 over 10. Remember, we're subtracting. So our answer is still going to be over 10. 76 minus the 5 is 71, minus the 7 is going to be 64. So this is the total time in class. But we're told that this time is spent equally in 6 classes. And they want to know how long is each class. These are very important things. Let me circle them in red. Total time is in 6 classes, and they want to know how much time is spent in each class. So we've got to divide this number by 6. So if we know that 6 is really 6 over an invisible 1, this math problem is the same as 64 over 10 times by 1 over 6. So we're keeping the first fraction, we're changing the sign in the middle, and we're flipping the fraction at the end. So we're using the reciprocal. So 64 over 10 times by 1 over 6 is 64 times 1 is 64. 10 times 6 is 60. So this equals 1 4/60. If we simplify, it's 1 1 over 15. So this is a 1 1/15 hour in each class. Okay, number 7. 7 is asking us to find the median of the data set. So you can do this a few ways. You could just number them here and then cross them out. I'm going to write them in order from smallest to largest. So the smallest is looking like 39, and cross it out. Then 36 is the smallest, so 36. Then 39, and then 44, then 48, then 50, then there's another 50, then there's 54, and then there's 55. So now we've got to cross them out. Find the middle number. 36 is gone, 35, and so on. Now we're left with 2 numbers in the middle, so we've got to find the mean of the middle two numbers. So we add them together and divide by 2. 48 plus 50 divided by 2, well, this equals 98 over 2, which equals 49. Our answer is C, 49. Okay, number 8. Number 8, we're told the unit rate of a proportional relationship is 1 over 3. So when we hear it's a proportional relationship, we need to remember the proportionality equation, y equals kx. K has all of these meanings like unit rate, constant of proportionality, rate of change, and also the slope has all of these. So we need to know these meanings, because when a question comes along like this and it says the unit rate in a proportional relationship is 1 over 3, we know straight away that K equals 1 over 3. We know the proportionality equation. We think this is the easiest question on earth. If y equals kx and k equals this, then y equals 1 over 3 x. And when we look for our answers, B is the only one that says it. That's why we need to know these definitions, because when a question like this comes along, it needs to be very easy. Okay, that was question number 8. Here's number 9. An irrigation system waters in circular patterns. Each irrigated section is a circle with a diameter of 40 feet. In terms of pi, what is the area of the irrigated section? So here we know it's a circular pattern. So I'm going to sketch out my circle. So let's just imagine it's a better circle than this. And we are told each irrigated section with a diameter. So the diameter here, remember the diameter is from one side to another through the center, is 40 feet. In terms of pi, so everything here has a pi in it. That's going to be good. We don't need a calculator. We don't need to use 3.14. It wants to know what the area is. Well, our area of a circle is pi r squared. Do not say pi r2. It's pi r squared. Now, we only know that the diameter equals 40. So if the diameter equals 40, we've got to remember that the radius is half of that, is 20. So if A equals pi r squared, the area equals pi times by 20 squared. Now, 20 times 20 is 400. So that's pi times 400, which we really like to put the number first. That's A equals 400 pi. And that is going to be C, 400 pi feet squared. Okay, number 10. Okay, number 10 is asking us for the mean number of days. And we are given a whole bunch of days right here. So what we've got to do first is add all of them up. So we've got to add all of these together. And then, after we find the sum of them all, we're going to divide by 1, 2, 3, 4, 5, 6, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. So we're going to divide by 20. So I'm going to pause, quickly add these up. So I just added them all up, and the answer I got when I summed them was 3, 4, 5, 1. And when I divide them, I get 172.55. And so D is our answer for question number 10. Okay, let's take a look. Number 11. Okay, so question number 11 says, yesterday Nina's lunch cost $9.80, and she left a tip of $1.47. So let's just write some stuff down. Lunch cost $9.80, so I can just put 9.8. Put the 0 if you really want. Okay, and the tip was $1.47. It says today her lunch cost $12.60, and it says if she leaves, if she tips at the same rate, so that's pretty much telling you the same proportion. If she tips at the same rate as she did yesterday, how much tip should she leave? And so when we look at this thing, we have two fractions, two ratios, and we're letting them equal each other. So at this point, what we can do is we can cross multiply. So that means we're doing our x times by the 980. So that gives us 9.8x. And that's going to equal, let me change the color, it's going to equal the 147 times by the 1260. So 1.47 times by 1260, or 12.6. Now I could work that out, but then the next step would be to divide both sides by 9.8. And then over here, whatever answer I get, I would divide by 9.8. So 9.8 would cancel. I'd be left with x equals, now I'm just going to grab a calculator to do this. I got an answer of 1.89. And so 1.89 would be the tip that she should leave if she wanted to leave at the same rate as what she did yesterday. Okay, moving on. Okay, so question number 12. This says which number line shows the inequality 4x plus 4 is less than 8. So the first thing that we've got to do is we've got to solve the inequality. So I'm just going to bring it over here. 4x plus 4 is less than 8. So in this case we just treat it as though we would with an equation, and we would subtract the number that's being added. So that would leave us with 4x, and then we're going to bring down the less than 4. Now to get the x on its own, we're going to divide by 4, so they cancel out. We've got to do the same to the other side, so we end up with x is less than 1. So we can definitely rule out this, because this is talking about greater than 3, so it's not going to be D. This one is talking about x is less than or equal to 3, so I'm not talking about this one. Now these two both have 1 with the circles, but this one for B is saying x is less than 1, whereas this one has a filled in circle and it's saying that x is greater than or equal to, so the shaded in means it could also be equal to 1. So as this was our solution, we are in fact talking about B. So B is the answer for number 12. 13. Now 13 says a rectangular, let's just go back up here, create a layer. It says a rectangular room on a blueprint is 2 inches wide and 5 inches long. So even before I read anything else in this question, I'm going to draw a rectangle. It's the smartest thing to do. We're told a rectangular room. Now it says it's 2 inches wide and 5 inches long. Now obviously this isn't the size of an actual room, because you wouldn't even be able to fit a hamster in there. Maybe you would be able to fit a hamster. But the actual room is going to be much bigger, and so I'm going to draw a much bigger rectangle as well, so we can pretend that this is the real size. Now we're given this scale, very important. It says 1:72. Now it doesn't say 1 inches to 72 inches, it doesn't say 1 inches to 72 feet. But just looking at it, because it doesn't have units, we know whatever is there, we have to multiply by 72. So 2 inches becomes 72, which is the equivalent of 1 inch, times by 2. So this side is going to equal 144. Now on the bottom, 5 inches becomes 72 times 5. So this becomes 10, and 5 times that is 350. So this becomes 360. So now what we've got to do, because let's face it, the question is saying what is the width of the room, and we were told that the blueprint, it's 2 inches wide. Really all we need is this. If we were told that it's 2 inches wide, we're looking for the corresponding side. So it has to be this one. It's 140. I was very tempted to go with C here. I was almost going to circle C as 144 feet, but because our original scale does not say inches to feet, it does not say this. So take a look. It doesn't say inches to feet. So because it doesn't say anything, we have to assume that if we're given inches in, it's also inches out. So that means that our width of this room is 144 inches, the same units as 2 inches. So if our answer is 144 inches, and we know that there are 12 inches in 1 foot, we therefore have to do 144 to find out how many feet. We have to do 144 divided by 12, which gives us 12 feet. So our answer is in fact A. This is a very slippery question. We've got to be very careful. Okay? Be very careful. And in fact, this 72 times by 5 and us doing this work, we didn't need to do this. All we were interested in was our widths, the width here and the width here. So answer to number 13 is A, 12 feet. Okay, let's move on. Number 14 is right here. We are told that Xander bought 3 shirts for $13 each. So let's just start writing, because I hate reading. So 13 each. 13, 13, and 13. A 5% shipping and handling fee was added to the cost of the shirts. So, and then it goes on to say, let me underline it in red, the actual question is saying, how much did he pay? Well, first things first, if he bought 3 shirts and they were 13 each, should come to $39. But then there's the fee, so we've got to add on 5%. So one way to find out the 5% is we could do 39 times by 0.05. So this is doing it using a decimal. And that would give us our answer. And then we'd need to add this back to the 39. And that would give us a total price. Another way to do this would be to do 39 times by 1.05. And that would give us the total with the shipping, not the tax, but the shipping fee. This one would just give us the shipping fee, and then we would have to add it back to the 39. The other way to work out these percents are to use the box method. So the box method is where we draw a little rectangle, split it into 4. We have 100 always in this cell. Then the top left we have the part over the whole, and then here we have the percent. So if we were looking for 5%, would be 5 up here. Now the part would be X, and the whole in this case would be our 39. So here we've actually created a proportion. The box helps us create a proportion. X over 39 equals 5 over 100. So there's a couple of ways to do this. So if we did it this way, we could then do 39 times 5. So we could do this just by doing the math, or 5 times 30 is 150. 5 times 9 is 45. Add them together is 195. And then 100 times x is 100x. To get x on its own, divide both by 100. So we get x equals 1.95. So we would have got 1.95 here. And over here, we would have actually got 40.95. Because this includes the original cost. This gives us our 105%, which is the total. So whichever way we do it, we've got to make sure we have our original $39, and then we add the tax back, which does give us 40.95. D is your answer for 14. Okay, so this is question number 15. Now, we've got to be a little careful here, because it says that the math club needs to raise more than. So we're looking at an inequality that looks like this. And it has to be more than 5,000. 552.35. It says a club account has a balance of this much, 67.25. Which inequality shows how much each of the 7 club members need to raise? So if they already have 67.25 and they have 7 club members, now let's just say M is a club member, they have 7 times by the amount that each club member is going to raise. So this is the inequality that we start with, 7 times the amount each club member raises plus the 67.25 that they already have, and this must be greater than 552.35. So in this case, I'm going to subtract 67.25 from both sides. I'm just going to treat it like it's a regular equation. But keep in mind that really it's not, it's an inequality. Now, let me just change color. So in this case, the 5s are going to give us 0. 3 minus 2 is going to give us 1. Here I've got to borrow. This turns to a 4. This is 12 minus 7 is going to give me the 5. I'm going to borrow again. 14 minus 6 is 8. Bring down the 4. So 4, 8, 5, 10. On this side, I'm going to bring down the same inequality, and I'm going to bring down the 7m. So now to get m on its own, I'm going to divide each side by the coefficient of m, the number in front of the m. So 7m divided by 7, that's just going to give me the m on its own. So I'm going to write in the m. And then I've got to do 485.1 divided by 7 as well, and that's going to give me 69.3. And remember, m must be greater than this. So in this case, our answer is going to be B, $69.30, because the missing hundredth place would in fact be a 0. So this is M is greater than $69.30. So that was number 15. So let's take a look at number 16. Number 16 here is just asking us to examine this equation. So when we examine it, we see 8 plus a negative 5 equals 3, which is a true statement, is a true equation. And we're told what is the distance from 8 to 3 on a number line. So even if they didn't tell us the stuff above this line, we could think on a number line, we have 1, 2, 3, 4, 5, 6, 7, 8. If we were asked for the distance between 8 and 3, we would know that we have to go back 1, 2, 3, 4, 5. We would have to go back 5. So the distance is in fact negative 5. So that's A. And this kind of shows you it here as well. Okay, number 17. Number 17 says, someone's reading a book with 12 chapters. The number of pages in each chapter is shown below. So we should have 12 numbers here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. It says, which histogram best displays these data? So we've got pages in the book as our title. We've got the number of chapters on the y-axis, and we've got the number of pages on the x-axis, and that's the same with each of these. Now, I'm seeing that, let's just refresh our memory how this data is ordered. The number of pages in each chapter is listed below. So these are the number of pages in each chapter. So we could analyze each of these. And here, just take a look, because the way that this has been shown on the screen is we've got A, C, B, D, so things are a little mixed up here as well. But this right here is basically telling us that between 10 and 19 pages, there are 5 chapters. So we could make a little graph about a little frequency chart about all this, or we could just try and count them. So let's see how many chapters are between 10 and 19. So this one would work, 10 and 19, 10 and 19, 10 and 19. So I'm just putting a dot between each of the ones that work. 10 and 19, 10 and 19. So is there anything else? Everything else should be outside between 10 and 19. So 1, 2, 3, 4, 5, 6, 7. So I've got 7 between 10 and 19, so it's not this one. This one shows me 7, which is correct. So possibly this one. This one shows me 7. So possibly this one. This one shows me 9, so it's not this one either. So now, let me just change the color. This one shows between 20 and 29 pages are 5 chapters, and this one shows me between 20 and 29 pages there are 4 chapters. So I've basically got to look through these numbers up at the top to see how many are between 20 and 29. So this one would count, this one would, this one, and that's it. And also I'm noticing that there is one chapter that has between 0 and 9. Now it's pretty hard to make out here, but it looks like, because there are 4 with my little red pen up here, I've got 4 chapters being between 20 and 29. It's going to be B down here, but it also looks like this has a line here, so that agrees with what I found, that one chapter is between 0 and 9 pages. So our answer is going to be B. Okay, so question number 18. So we're told a school auditorium can hold 386 people. So I'm going to write 386 max. So that's the maximum number of people. For a choir concert, there will be 23 staff members. So 23 staff in attendance. Which inequality describes the number of people each of the 33 choir members can invite to the concert to fit in the auditorium? So I'm going to assume that the 33 choir members themselves are up on the stage, and the auditorium is allowing people to sit in the seats outside of that. Now we're told 386 max can go in these seats, and 23 of them are staff, and each of the choir members, each of the 33 choir members can invite so many people, and it's that so many people that we're trying to find. So if each of them invites 1, then there'll be 33 extra people in the seats. If each of them invites 2, there'll be 66. If each of them invites 3, there'll be 99. So one way of writing this is 33 times some variable. So I'm going to put G for the guests. So this is the total choir members guests. So therefore we're asked to figure out which inequality describes the number of people that each of the 33 choir members can invite. So we know 386 is the max. So whatever I write here must be less than or equal to this. So we know there's 23 staff, and we also know 33G represents the total number of people that the choir will invite. So now as I go to simplify this and solve it, I'm going to subtract 23 from both sides. So subtract 23. Now the 23's themselves both cancel out, so I'm going to put a line through those. Now over here, 6 minus 3 is 3, 8 minus 2 is 6, and then bring down the 3. Keep the same inequality, and I'm going to bring down 33G. Now in order to undo 33 times G, I'm going to divide by the coefficient, divide by the 33. Got to do the same to both sides. So in this case I'm left with G is less than or equal to 11. And so looking at my answers, I've got B, which has the exact same thing. G is less than or equal to 11. And so each choir member can only invite a maximum of 11 people. So our answer to 18 is B. Consider the box plots below. And it says, what is the interquartile range for each of the box plots? So this question, you really have to understand what makes up a box plot. And so this number right at the end is the minimum, is the smallest number. So in each case it's 220. At the end over here is the maximum. So if we were just after the regular range, we would do 360 minus 220 and we'd get our 140. But it's not asking for the range, it's asking for the interquartile range. And so at the start of each box you have your quartile 1, at the end of each box you've got your quartile 3, and in the middle you've got your quartile 2, which is also known as the median. Now your interquartile range is basically the distance between Q1 all the way to Q3. So in this case, in the first one, we have got, I'm trying to do this as neatly as possible, but in the first one we've got 320 minus 250, which equals 70 for our interquartile range. Now for the second one, let me just change the color to make it a little clearer. For the second one, we have got, so looking at this right here, that looks like 310. So 310 subtract 240, which also gives us 70. And then for the third one, let me just do some dotted lines as well. Remember, we're doing quartile 3 minus quartile 1. We've got 340 minus 270, so that equals 70 as well. So the interquartile range for each of them is always 70. So B is our answer for number 19. Okay, number 20. Okay, so in this question we are told that Dennis has made a scale drawing of his backyard. Using the scale, 1/4 of an inch is the same as 3 feet. Now we're told that the rectangular swimming pool, so straight away we're going to draw a rectangular swimming pool. We're told that this rectangular swimming pool was 2 inches long in his drawing and 1 inch wide. And it wants to know the area of the actual swimming pool. So we're going to draw the actual here as well, and we're going to label it with the actual dimensions. So with this scale in mind, 1 inch, we have to think, what is it going to turn into? So I'm going to set up my proportion. So I've got my inches to feet, and our scale gives us the first ratio, 1/4 is to 3. Now that ratio is going to help us, because now we're going to figure out the other ratio using corresponding sides, which is 1 inch is to x. So I'm going to put 1 over x. And so when I find out x now, that's going to tell me what is the actual number of feet is the width of the actual swimming pool. So by cross multiplying here, now I'm just going to circle to show the cross multiplication, or group rather. I'm going to group the 1/4 and the x. That's going to give me 1 over 4 x equals, and I'm going to do 3 times 1, which is 3. So in order to get x on its own, I'm going to multiply both sides by 4. So in this case I'm going to get x, because 1/4 x times by 4 is just 4 over 4x, which is 1x. So x equals 12, and our units, because the x is on the bottom now, is feet. So I just calculated this side to be 12 feet. Now, if I change the pen over to green, now we're trying to find out what the length of the pool is. So let me call that y. So it's the same proportion setup, which is inches over feet, and we're going to use our scale for the first ratio, which is 1/4 is to 3. So this is what we used again, which is the scale that we were given up here. So 1/4, 1/4 is to 3, as 2 inches is to y. So now when I go to solve this proportion, I've got 1/4 times y, which is 1/4 y, and that equals 3 times 2. So 3 times 2 is 6, that equals 6. It's the same thing. I'm going to multiply both sides by 4, and that's going to cancel out my 1/4, so I'm going to end up with y equals 6 times 4 is 24, and that's 24 feet. So I've now got the real width and the real length. And so just looking back at the question, this question is asking us what is the area of the actual swimming pool. So because this is a rectangle, we know our formula, A equals length times width, and in this case that equals 24 times 12. And so one very quick way to do this is to do 10 times 24, which would give me 240, and then 2 times the 24, which would give me 48, and when we add them together we get 288. And remembering the units here are feet, so the feet stays, and because it's area, it's squared. So 288 feet squared is the area of the actual swimming pool here. And so our answer is C for number 20. Okay, so 21. For number 21, we're told Cleo wants to join a gym, but there's an initiation fee of $24.99. So I'm just going to write that there, $24.99. And each month there's a cost of $12.50. So on top of the $24.99 original initiation fee, she also pays $12.50 for each and every month. So I'm just going to put an M there. So if it's 1 month, it's going to be $24.99 plus $12.50 times 1. If it's 2, it's going to be $12.50 times 2, and then add on the $24.99. Now in this question we're told that Cleo pays $174.99. So we're basically told that this is the initiation, this is the cost per month, and that this is what she paid in total. So we can let these two things equal each other. So now we've got a two-step equation right here. So my first step is, because the M is there and it's being multiplied by $12.50, and then this is being added, we're going to subtract $24.99 from both sides. Subtract $24.99 from both sides. So if I draw my line all the way across, these cancel. The $12.50 comes down, but I can just write that as 12.5. We don't need that trailing 0, as it's the last digit and it's after the decimal as well. So 12.5m equals, over here when I subtract, I get a couple of zeros, and then this turns into 150. So even these zeros right here, they're trailing, so I can get rid of them. So now to get the m on its own, I've got to divide by 12.5. Do the same over here as well. Divide by 12.5. And so when I do this, because I'm dividing by the coefficient of the m, that means that the coefficient is going to disappear and we're going to be left with the variable itself. So that's what I'm going to do right here, is I'm going to cancel out the numbers and I'm left with m equals, now 150 divided by 12.5 is going to give me 12. and so m equals 12 and the units are months. So our answer is C. Now we're asked in this question, Walt is gathering data about how far students travel to school each day. What is the best unit of measure to use when gathering his data? Well, I don't think that centimeters, something that's about this big, is a useful unit because they are so small, and so the number of centimeters that people live away from school is going to be thousands and thousands of these centimeters. Kilometers might work, that's a much bigger distance. Meters, so a meter is 100 times these things times a centimeter, 100 times a centimeter, so still this is kind of a very small unit as well. And so we'd only really consider meters if everybody lived across the street or down the block, but that's probably not the case with a school. And millimeters, in 1 centimeter, there are 10 millimeters. And so this is even worse. If there are 10 of these little things in there, I don't think that it's worthwhile measuring how far students live away from the school in millimeters, because that's going to give us some ridiculously huge number as well. So kilometers, 1 kilometer equals 1,000 meters. And so this seems like the best unit to use when gathering his data, kilometers. Okay, question number 23. Now 23 is one to be very careful of because we have a negative coefficient in front of our x. And so if this involves a step where we have to multiply or divide by a negative number, the rule is that we must flip the inequality. So I'm writing this rule down because it's very important that we remember it, and it's probably going to be in the state tests. So if we multiply or divide by a negative number, we must flip the inequality. So let's take a look at what this really means. So I'm just going to write it out again. I've got negative 2x plus 4 is greater than or equal to 6. So let's get rid of this 4 right here. So I'm going to subtract the 4 from both sides. 4's cancel. And I'm left with negative 2x is greater than or equal to 6 minus 4 is 2. So now what I'm going to do is use the green marker because I need to divide by the coefficient of the x. So my coefficient here is negative 2. Now this is when alarm bells should be going off in your head because we're dividing an inequality problem by a negative number. And the same if we're multiplying. If you're multiplying or dividing by a negative, that's when we have to flip. So first things first, negative 2x divided by negative 2. The 2's cancel and negatives become positive, so we have x. 2 divided by 2 would be just 1, but it's 2 divided by negative 2, so it's negative 1. Now here, this inequality, the rule is we divided by a negative, so this inequality must flip. So it becomes x is less than or equal to negative 1. So this one up here is x is greater than or equal to negative 1 because it's shaded to the right and it's filled in, so it's or equal to. This one here, b, is x is less than or equal to negative 1. So this is our answer. But the other ones, let's just go through them. This is x is less than 1 because the circle's on 1 and it's not filled in, so it's just less than, it's not or equal to. And D is x is greater than 1. Again, it's shaded to the right, so it's greater than. and it's not or equal to because the circle is empty. So our answer for 23 is B. Okay, moving on, looking at number 24. Now 24 has this ruler symbol, and it's unlikely that the state test this year will include such a symbol. They will just expect you to know to use a ruler. So if you're asked to measure something, then you need to decide, is it a protractor that you're using, or is it a ruler? So this is something that you must know which one to use. Now Juan's classroom is shaped like a rectangle. The room is 40 feet long and 25 feet wide. And so we're asked which rectangle could be a scale drawing of the classroom. So I'm looking at these right now, and obviously these are on the screen. I'm not able to measure them, but we're looking at something that's 40 by 25 feet. So I'm not going to multiply these, I'm just writing them down because these are the dimensions. Now C has a really short bit and a really long bit, and it doesn't look like it would match this. It looks like 40 by 25 wouldn't be a square, but it would be closer to a square. So this one is nowhere near a square. Now it's not going to be a square because it's not 40 by 40, but it would just be a little closer. Okay, so now I'm looking at the others, and I'm seeing right here that this one is closer to a square, but it's a little too much like a square, so I'm just going to cancel it. And obviously if this was in the test and you had this on paper, you could measure it, and you could check the to see that, let's just say the length and the width. If your length is 40 and your width is 25, whatever you measured these as, the length and the width, the length and the width, you would need to make sure that this is the same proportion for the length and the width of whichever one of these would work. Now I'm just looking around right here, and you know, it's pretty close. It's pretty difficult for me to see right here. I'm thinking that it is more like D, because this is a little too square-like. However, you know, it is pretty close without a ruler to eyeball this one. But I'm going to go with D. Don't worry if you couldn't put an answer to this, but if you do have this sheet, the page in front of you, you should be able to measure it and check to see if I'm right or if the answer is A. Okay, moving on, this is number 25. So for question 25, we're told the table below shows a number of customers served each hour at a local deli. It says, what is the mean of the data set? So in this case, we're going to add them all up, and then we're going to divide by how many there are. So there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So 10's a good number to divide by. So now I just need to add them all up. So I'm going to very quickly do this right now. Okay, so when I added them up, I got 450. So 450 divided by 10, well, when you divide by 10, you just move the point over 1 to the left, so this gives me an answer of 45. So C is our answer for the mean of this data set. Remember, the mean is where you add them all up and you divide by the number of them. Now in this question we're told that Sarah was cutting fabric for a quilt. She cut a strip of fabric that was 19 1/8 inches long. So I'm going to draw this strip of fabric. I'm going to take the red marker and I'm going to write the length. We're told it's 19 1/8 inches long. And she cut it into 5 equal pieces. Now, so I'm going to circle this. She cut it into 5 equal pieces. When she was cutting, Sarah had a piece that was 2 1/4 inches long. Now this is I think it's a badly worded question, but you know, they could word something like this. So basically she cut this into 5 equal pieces, but she was still left with something at the end, she was left with a piece that was 2 1/4 inches long at the end. But the five equal pieces that she had were like this. So let me see if I can roughly show it as 5 equal pieces. Okay, so this was the first piece, the second, the third, the fourth, and the fifth, and then she was left with this 2 1/4 inch piece left. So it wants to know how long was each piece that she cut for the quilt. Well, let's keep in mind that this 19 1/8 is representing the distance from the left side all the way until the right side. And so the math that we have to do here is we have to take our 19 1/8, we have to subtract the bit that's left at the end, so we're subtracting 2 1/4, and then whatever we get is going to be the distance from here to here of all 5 pieces. So then we would have to divide this by 5. And so in this case, what I'm going to do is I'm going to subtract the 2 first. So if I just take away this 2 from the 19, I'm going to get 17. So I've got 17 1/8 subtract 1/4. Well, okay, so this is slightly problematic, but what we can do is we could write this in terms of eighths. So if we're subtracting 1/4, we're really subtracting 2/8. So I'm going to get rid of this fraction. It's still 1/4, but it's 2/8. And then we're going to remember to divide by 5 in a minute. Now, this says 17 1/8, and we're subtracting 2/8. So if I was just subtracting 1/8, it would take me down to 17 even, but because I'm subtracting 2/8, I'm going 1/8 down to 17, and then I'm at 17 and I'm taking away 1/8. So if you take 1/8 from 17, you go into 16, and because you've just taken 1/8 off, you're at 16 7/8. So I'm at 16 7/8. That's my answer for the parentheses, and then I need to divide by 5. Now there's a few ways to do this as well, but one way that we could do it just to avoid any problems is to turn your 16 7/8 into an improper fraction. So what we would do here is we would do the C move. So I'm going to take the red. So we would do 8 times, so remember this is multiplied, times 16, and then we're going to add it to the 7. So 8 times 16 is going to give us 128, and then when we add the 7 on top, we're going to get 135. So this becomes 135 over 8 divided by 5. Now when we're dividing a fraction by a number, and really this 5 is 5 over an invisible 1. When we're dividing fractions, what we have to do is keep the first fraction, but then multiply by the reciprocal of the second. So this becomes 135 over 8 times by 1 over 5, which equals 135. So remember, when we're multiplying fractions, we don't cross multiply, we actually multiply across the numerators and then multiply across the denominators. It's very different to cross multiplying and solving proportions. So 135 stays on top, and on the bottom 8 times 5 gives us 40. So if we simplified this right now, 40 goes into 135 3 times, because 3 40s are 120. Our remainder would be 15, and then it would go back over the 40. Now I'm looking here, and the only one with 3 as a whole number is D, so I know it's going to be D, and it's 3 over 8 because when this simplifies, 5 goes into 15 3 times, and 5 goes into 40 8 times. So this is my answer, but as soon as I had 3 and change, I know that my answer is going to be D over here. So this is a very tricky question, but I think one of the crucial parts was when we had 17 and 1/8 and we're subtracting 2 eighths. That takes us down to 17, and then we've got to take away another 1/8 as well. Okay, so D was our answer to number 26. Okay, here's number 27. Okay, so in this question, Antoine gathered the ages of 15 parents of students in his school. He recorded the data in the table below. So it's always worthwhile checking this data. We've got 3 bits of data, 3 rows, and we've got 1, 2, 3, 4, 5 columns. So 3 times 5 is 15. So that matches with this. Okay, so we know we've got 15 sets of information in there. Wants to know the median age of the parents. That's the middle number. So one of the first things to do is to put them in order. Now I see 26 is there. I think it's the only one in the 20s. So I'm going to cancel that. So then 30 we've got. So it's 26, then 30, then 31, then 32. Then I'm seeing another 32, so I'm going to write that here as well. And then if I keep going, I know I've got a 36 up there. I'm just looking to see if there's anything else. You know, I'm now noticing that I missed this 28. So I've got to be very careful here. So I'm going to put the 28 back in there. Okay, so I'm going to cancel that now. Alright, so I have 32, I have 36, I have 38, and then we're into the 40s, so I got 42. Then I'm noticing I've got 1, 2, 3 43s, so 43, 43, 43. Now I'm trying to squeeze them all on, but I might run out of room here. But then it's 51. I'm going to run out of room. Then 54, and then 56 is the last one. Now, you know, if I hadn't have made this mistake with missing out the 28, it would have been a little neater. If I tried to get everything on one line, it would have been neater. But you know, sometimes it's going to be a little messy. You can just try our best, I guess. Okay, now the median age of the parents is the one in the middle, so we've got to be careful that we go 1 for 1. Cross out the first, cross out the last, then second, second to last. Now I just got to be neat and remember to go 1 for 1. Almost there. Okay, and this time we are just left with one number in the middle. If we were left with 2, we would need to find the mean of those to give us the median, so the number in the middle of the 2 that were left over. But here we're left with 38, so our answer is C for number 27. Okay, number 28. Okay, so here Daphne has 3 days to drive 932.4 miles, and she has 3 days to do it. So always highlight these things, make the information that's important very clear. And it says approximately how many miles does she need to drive each day. So if this is a total distance and she has 3 days to do it, if we split this into 3, so we're dividing by 3, that should give us our answer. So even straight away we could look at the reasonableness of some of these answers. If we've got around 900 and we're dividing by 3, we know our answer is going to be around 300. It's not going to be 929, that would be dividing by close to 1. This answer looks like we're multiplying our number by 2, and this answer looks like we're multiplying our number by 3. When we're not, we're dividing by 3. So we could do the actual math, but A is the answer. If we were doing the math, the first number we say would go in the house, 932.4. 3 would go outside, 3 into 9 goes 3. 3 times 3 is 9, take away 0. And bring down the 3. 3 into 3 goes 1. 1 times 3 is 3, take away, we get 0, bring down the 2. 3 into 2 goes 0, put the point. 0 times 3 is 0, and subtract it, we've got 2, bring down the 4. So 4 goes there, 3 into 4 goes 8. So we do get 310.8. So that's our check for A, but we knew it was A straight away by looking at 900 and change divided by 3. That gave us around 300. Okay, so that was our answer to 28. 29 is here. So now number 29 is talking about a survey being conducted. And it says, a survey conducted at a local pet store included a section about dogs. Which of these questions is a statistical question and should be included? Okay, so how many legs does a dog have? Well, that's not really a statistical question. It's just a fact that most people will have an answer of 4 for. So it can't be A. B, how many dogs do you own? So that's statistical because that changes based on different dog owners or even non-dog owners. Does a dog go to a veterinarian? Well, that's not asking them specifically if they have a dog and it goes to a vet. It's just saying, does a dog go to a vet? So it's a little bit of an odd question. It's either a yes or a no, and really it's not about their particular dog, it's just any dog. And D, is a kennel a shelter for dogs? And again, that's a fact, or that's just an opinion question rather than a general opinion question rather than something specific to that person. So it's not D either. So B is our answer because each question to each person could yield a different answer based on what they have. Do they have 0 dogs, 1 dog, 2 dogs, 3 dogs? So it's going to change based on them and not just their opinion of the world, an opinion of dogs going to vets, or opinion that all dogs must have 4 legs. This is a statistical question, and the answer is B for number 29. Okay, next question is number. So number 30 says Orlando and Daisy ordered a pizza for lunch. Okay, so it says ordered a pizza, so I'm assuming that they ordered 1 pizza. It says Orlando ate half of the pizza. So Orlando ate 1/2, 1/2. And Daisy ate 3/8 of the pizza. So 3/8 is pretty much a half, but not quite, so I'm gonna leave a little left over here and say that Daisy ate 3/8 of the pizza. It says how much of the pizza did they eat together? So at first I thought they were going to ask for what is this little leftover piece, but it turns out that this question says how much did they eat together. So I'm going to take 1/2 and we have to add 3/8. So we've got to be careful, we're not just adding across. This isn't a multiplication problem. What we need to do is we need common denominators. So I'm noticing that 2 and 8, the common denominator here could just be 8. So the 3/8 would stay. Now to turn this 2 into the 8, what we did was we multiplied by 4. So to give us an equivalent fraction to 1/2, we must do the same to the numerator, times by 4. So therefore this 1 becomes a 4. So 1/2 is the same. We didn't change the fraction. 1/2 is 4/8, but just writing it as 4/8 allows us now to have a set of fractions with common denominators. And so 4/8 plus 3/8 equals 7/8. And so 7/8 is our answer, and that is D.